Okay, so our last task for today is we're going to look through a couple of examples and see if we can code these two items. And I'm going to come back here so I can see. So essentially what we're going to do is try to code two items for each of these abstracts. First, what is the unit of assignment? Individual or cluster? So we're individual people assigned to conditions, or we're larger groups assigned to conditions. So people versus, say, classrooms or schools or groups. And then, are those units, whether they're individuals or people, are they randomly allocated to conditions? So is it a randomized trial or not? And so we've got yes, no, and unclear. Seems straightforward, right? These are real excerpts. Okay. I'll read it, but we can also have a minute to digest for those of you who want to look at it. The SFH peer sexual health intervention was evaluated using a randomized control group design. To reduce contamination due to the exposure of students to AIDS prevention messages on television, this evaluation was restricted to boarding schools. Secondary schools were randomly assigned to intervention and control groups. Students in 10th, 11th, and 12th grade were randomly selected in intervention and control schools and given a baseline assessment of their normative beliefs and knowledge about abstinence and condoms and their personal risk perception of contracting HIV. So, what is the unit, or is this an individual-based trial or a cluster-based trial? Cluster. And why do you say that? Yes. So essentially they said secondary schools were randomly assigned to the intervention and control groups. Okay? And then is it a randomized design? Yes. Now, here, that's because they told us that they actually randomly assigned these conditions. Up here, they said they used a randomized control group design. I would not necessarily believe that because we'll see some bad examples in a minute. So this one's pretty straightforward. It's a cluster design. It's an RCT. Okay, let's look at number 2. A quasi-experimental design was used to evaluate a peer education intervention. 11 schools in the region were identified. Of these 11 schools, 2 were dropped because they had received a peer education intervention from the Society for Family Health in the year 2000. Another school was dropped because it was a Catholic mission school, and 2 schools could not participate in this evaluation because the timing of data collection conflicted with other activities. All 5 remaining schools were included in the study. Of these 5 schools, 3 were randomly assigned to the intervention group and 2 to the control group. So is this an individual or a cluster-based assignment? Cluster. So they said 5 schools were assigned to conditions, not people. And then is it a random assignment or not?
Unclear.
Well, the numbers probably, yeah, in that you just get so used to them. So the numbers don't add up, but for those of you who were saying, did anybody say it is a randomly allocated? Okay, and why are you saying yes?
Once eligible schools are selected, some were assigned to the treatment, some were assigned to the control group.
And randomly.
Right.
So that appears to be random allocation. Those of you who said no, why did you say that? And that may be more of an issue of potential selection bias. Yes. Anything else that's fishy? There's something real fishy. Yes. Their first sentence is that it was a quasi-experimental design. So they say it's a quasi-experimental design, but that they randomly allocated schools to conditions. And so if we assume that this last sentence is correct, This is a cluster randomized control trial. It's not a quasi-experimental trial. So this is it's a real example, but I just wanted to highlight that, you have to be wary sometimes. And also, if you were reading abstracts, you have to be wary about these design issues, because I cannot tell you how many times I've seen people refer to cluster RCTs as QEDs when they're not, or referring to random selection of participants as random assignment, which it is not. So those are kind of common design problems. Okay, I think this is our last one. A randomized controlled design was employed. 4 schools in Benin City were randomly selected to participate in the intervention. Since it was impossible to restrict the influence of a community-based intervention to the specific schools chosen, a control group of 4 schools was randomly selected from the schools in a nearby town. In order to have equal representation of boys and girls in the intervention, we sampled single-sex schools and co-ed schools separately. Thus, at the onset, we divided the city into 2 sections, a western section which received the intervention, and an eastern section to act as the part where the control schools would be selected. It's real. So, cluster or individual? Cluster, these have all been cluster. Is this random allocation to conditions or not? I'm seeing a no. And why do we say no?
So randomly selected, but not randomly assigned.
Exactly. Randomly selected, and they just split the city into east and west, and said, okay, the west side is going to be the intervention, east side is control, but they called it a randomized controlled design.
Well, up above, they say the control group's coming from a nearby town.
Exactly. So all of this is to say that coding 2 simple items, which seem like they should be easy, often are not as easy as they seem. Maybe in your literatures they're nice and clean, but I've seen lots of literatures where something as simple as unit of assignment and random allocation to conditions is not as clear as it seems like it should be. So be aware of that when you're training your coders. Okay, so we finished a little early. Do we have questions? Because really today was the gauntlet of getting through systematic review methods. We've covered a lot. Developing research questions, establishing eligibility criteria, developing search terms, developing coding manuals, and collecting data. Jay, did you?
Well, I guess I'm getting kind of wiped out after this many hours.
Yeah.
But I mean, how often do you get to this point and just go, I don't know. I mean, there's so much contradictory evidence and the designs are all so different. I mean, I can just envision doing this for several months and feeling more confused than when I started in some way.
Don't get discouraged. So I will say that feeling will probably pass after you've done a scoping review. Yeah. I'm serious. I think that is a normal reaction, but it will pass once you do a scoping review, start to find some of those primary studies that really are the ones that you're interested in, and once you can narrow down your eligibility criteria and your research question, I don't think it will be as bad. You just seem so discouraged.
No, I think there's a kind of pernicious kind of consequence of this, though, that oftentimes then the solution for like big funding agencies is say, all right, damn it, we're going to do the randomized control trial with perfect designs. They haven't really thought through the questions well, and they get totally boned on something like attrition or an intervention that doesn't really make sense with the population that they're talking about or something like that.
Yeah. I think I've had this discussion individually with several of you, but not as a group. So I think it goes well with your comment here, Jay, which is, sometimes there are spaces for empty reviews or systematic reviews where you find no studies that meet your inclusion criteria, or maybe only one. And so you can't do a meta-analysis in that situation, but those empty reviews can be a powerful technique to say, hey, supposedly this topic matter is interesting and relevant to people, but we actually don't have any good quality research on it, or the quality of the research that we have is so poor that it didn't even meet our inclusion criteria. And so there are spaces for those empty reviews too, which can actually be used to address some of those issues you were just talking about. Of, maybe we have all of these interventions that are being done, but they're problematic or they're not appropriate for the populations that they're working with. So you can use those as a tool. Now, you have to then ask yourself, if you go into it knowing it's going to be an empty review or a small review, is it worth the time and the effort? But sometimes being able to make that claim that you have empirically demonstrated that there really is no good quality evidence on something, that can be just as powerful as a meta-analysis of 30 studies. So I don't know if that makes you feel better, but David, did you have a question? No?
So
Yes.
I guess the one thing that, and this is just my perspective, but sort of picks up on what you were saying, is that this is not an inexpensive undertaking. And I'm sort of at a loss that how could you afford to do something like this without significant funding?
Well, it depends on the scope of your review. And really, when we're talking about systematic reviews and meta-analyses, the cost is really in personnel.
Right.
And so I do agree, I don't do large systematic reviews unless I do have funding to support that, because it takes my time, it takes my consultants' times, who are my content experts and my methods experts, and then really a lot of data collectors' times. Now, that's not to say you can't do systematic reviews without funding. Plenty of people do, especially if you've got smaller scoped reviews where maybe your literature search yields 300 abstracts. You can review that in probably an hour or two. And so if you think about that, really it doesn't take quite as much time. And if you're in a position where you might have motivated graduate students or colleagues who are interested in getting that publication out there, it is something people can do on their own time. It might take slightly longer, but I've seen it done and it happens all the time. So don't get too discouraged that that you can't do that. And I will say that for my graduate students, a nice carrot is that systematic reviews and meta-analyses are some of the most highly cited articles. So not only do you get the benefit of, once you've read and coded these studies, you're now an expert in the topic because you've read everything that's relevant. So you know this is your literature. So that's very appealing to students or junior faculty. But two, for those who that is an incentive, having highly cited articles, and being able to make that impact is worthwhile for doing it on nights and weekends. So that's one way to justify it. Yeah.
What is your experience on timeline for a systematic review? How much can it vary, and what should someone expect?
I think it can vary a lot, and the only reason I hesitate is I don't think I'm a good person to answer. I usually work on very large reviews where we have hundreds of studies, and those reviews can take 2 to 3 years. I have not worked on a lot of smaller reviews. The teen pregnancy prevention one that I am working on now, that one is a smaller review. It's not a systematic review, but it's a meta-analysis, and I think we're coding 45 studies, and we're doing it within 6 months, so it's just kind of an intense sort of 6 months. We'll see if we actually make it. But it's a staff person issue. So do you have the people who can really go through and somebody who's managing the project all along? And I think you can do those rapid reviews. I am very dubious about a rapid review that's like a month turnaround. I don't think the quality of that is probably very good. But I've seen really high quality reviews done in 6 months' time if you've got the staff dedicated to it. Yes?
So you could have a meta-analysis that is not a systematic review?
You could. And so we didn't talk about that too much because all Campbell reviews will be systematic reviews. But you certainly can do a meta-analysis where you're quantitatively synthesizing findings across studies. Those studies just may have been identified a different way. So in the teen pregnancy prevention project that I'm working on, essentially the Office of Adolescent Health has funded 40 trials, and they want us to synthesize the results from those trials. So they're not interested in what's been done by other people. They want to know in these highly controlled environments where they were providing technical assistance, what are the effects of the interventions? Now, of course, when you interpret those results, you have to be cautious because it's not the totality of the evidence, but it's, of this sample. You often see that too with pharmaceutical trials. If they're developing a new drug, they might do 5 trials and then meta-analyze the results. But most of the time, if we do a meta-analysis, we want to make generalizations to the larger body of evidence, so we want that based on a systematic review.
I have another question regarding coding. Is it sometimes the case where people do far less detail and mainly code for the inclusion-exclusion criteria, the outcomes, the points of interest with regard to the original research question?
I think it's certainly a possibility. I would say that probably, in general, people code more at the full text level than at the eligibility level, just because you want to be able to describe your included studies. But certainly that could be at a much more circumscribed nature, where you're just saying, here are the populations, participant characteristics, type of intervention, and that's it. But really it depends on your goal, it depends on your research question, it depends on your literature, what you're going to be coding at the full text level. Other questions? Well, you guys have been a great group today. I'm excited about tomorrow because we get to do what I think is the fun part, which is the statistical part.